they are leftovers, along with asteroids, they are leftovers from the formation of the solar system 4.5 billion years ago. They're mainly made of ice and other volatiles, frozen ice, frozen carbon, frozen water, frozen carbon dioxide, frozen carbon monoxide, dust, a lot of organic molecules and stuff, all kind of mixed together. Most of them that we know about reside in the far outer regions of the solar system, in an area we call the Oort cloud. Some of them also reside in an area beyond the orbit of Neptune in what's called the Kuiper belt. The vast majority of comets that we know about do reside there, but as a result of various gravitational influences, every now and then some of them get kicked into the inner solar system, and that's when we see them. The planets will capture some of them. Jupiter, with its large gravity, has captured a number of comets into short period orbits, and they return every 6 or 7 years. Some are captured in orbits with longer periods, 10 years, 20 years. Some are intermediate periods, 50 years, 100 years. Halley's Comet, for example, being one of those. And then there are longer period comets. Hale-Bopp, for example, the one that I've been associated with, has an approximate orbital period of a little over 2,000 years. So we have comets all over the solar system, but just the vast majority of them are very far outside. Since they are the leftovers from the formation of the solar system, they are pretty much unchanged from that time. Studying them gives us insights into what the conditions were like when the planets were formed, and of course that includes Earth. And we also have strong reason to suspect that comets delivered both water and the organic substances which led to the formation and evolution of life here on Earth. Comets delivered those things to Earth, so we're getting insights into our own origins when we study these things. There is a possibility of impact threat, so we study comets for that reason. Also, they contain resources that, at least in theory, we could use and utilize in future civilization if we ever get to such a point. Over geologic timescales, yes, they have. We don't know of any instances, at least in recorded history, where a comet has hit Earth, but they are out there, and over a long enough period of time, a comet comets will hit Earth over a long enough period of time. There is one comet that we know about that does possess a potential threat. It's Comet Swift-Tuttle, and it is the parent comet of the Perseid meteors, and that orbit of that comet essentially intersects Earth orbit, and should Earth and that comet arrive at that point at the same time, we could be in for an interesting experience. But the comet has an orbital period of about 130 years, and it will at least be several millennia before there's any potential of an impact from that object. Of course, there's plenty of unknown long-period comets that could come in and make close approaches to Earth, or theoretically could hit Earth. And it's always a possibility, but there are many, many other things that are far more possible in terms of threats to Earth, threats to us. So the threat is there, but it is very minor, I guess is the way I would phrase it. That's actually a very good question, and I'm not sure there's an actual answer to that, because there are objects that kind of share characteristics of both comets and asteroids. And again, they're both leftovers from the formation of the solar system. Asteroids are made of the more harder substances like rock and metal, whereas comets are made of more volatile substances like water ice, carbon monoxide ice. But you have objects that are kind of halfway between. They've got rock and they have a lot of ice too. So what do you call them? Comets, sometimes they just run out of the volatiles. They're dead comets, and at least when we look at them, they look like asteroids because they don't exhibit the cometary phenomena like a tail and a comet or so on. So there's a very fuzzy dividing line between one phenomenon and the other, one object and the other. For observational purposes, we generally define the differences. An asteroid does not exhibit cometary activity like a tail or a coma, whereas a comet does. But in terms of Their physical nature, it's kind of fuzzy right at this point. There are definitely objects, there are asteroids that are very much in orbits that are representative of comets, and there's reason to believe that those are dead comets. As far as how you define them, that's kind of a matter of definition.